Alright. We're going to talk about heat versus temperature. I'm going to move the quiz to Monday like I did first period just because I've got enough doggone papers to grade this weekend. And because I did it for them, I'll do it for y'all too. Because we're about 10 minutes, maybe 10 minutes ahead of them in first period. Let's see. I'll just use a blank right now. All right, so we're going to talk about heat versus temperature today. And what the differences are and how to calculate the two. Now, the calculations we're going to do from today through December. Now that we know how to use significant digits, all of those calculations have to be done in the correct significant digits also. Does everybody understand that? Don't stop with that nonsense. For those of you who need titles, you can put heat versus temperature in your notes. All right, we're going to start with temperature, and then we'll do heat. Now, temperature is defined as a measure of the average kinetic energy of the particles in a sample of matter. And particles is plural up there, but it ran off the board. Is that what it hit? Okay. I knew it hit something. I had left from the volleyball game because apparently Judy Michael is, well, he used to be here, was Judy Copley. Long ago's last name, Dr. She's going to the game. I got sent home. So I had to leave. I knew it hit something. 4:30, 4:40, somewhere around there. There were a couple kids outside. I bet they did. They took it. I figured it hit the building. I just didn't know what it hit in the building. Toby Wicker. Yeah, I forwarded it to her from my iPad when I saw it come in last night. For you, but yeah. I mean, there's something blowing. But it's just humid and hot. Why are they not plugged in?
There's 3 of them in there.
Oh, yeah, I can do that.
Why not?
Okay. Maybe if I said show me a text, you'll bring me a fight. She might be up by now.
I just want to go to the game. I know, right? Sorry. Everybody shooter? No, it's not much.
That's right, we're just gonna bring it to dehumidifiers. Alright, tell me this. Apparently the air hit the controller, she said. So I don't know what that means for us now. Could be a while without air. Alright, so a measure of the average kinetic energy. Tell me what you remember about kinetic energy from another science class.
Energy of motion.
It's motion. Alright, we're not gonna do a lot with the differences between kinetic and potential. Those of you who are talking, stop. Okay, 28 of us in here. We can't have a lot of sidebar conversations and y'all hear me. I'm not going to scream. I am loud. My children are forever shushing me. However, I'm not going to scream. So, it's a measure of the average kinetic energy of the particles. So we're measuring how fast they're moving. That's all temperature is how fast. So, tell me this. What units do we use to measure temperature? Okay. Fahrenheit is degrees F. All right, I heard Celsius,
Kelvin.
which is abbreviated degree C. And Kelvin has no degree symbol. Okay, it's just K. Okay, Kelvin has no degrees. Thanks, Rector. All right, so it's degrees F, degrees C, and Kelvin is just a K. It's the only one that does not have a degrees. All right, we're caught up? All right, so what piece of equipment do we use? And we're doing this because I'm going to show you how heat is different. What do we use to measure temperature? Those of you who can't spell it, it's thermometer. That's the easiest way to remember it. Instead of jacking up the spelling constantly, it's thermo and meter. Okay, thermo and then meter. Now, the formulas that we're going to use. That's why I told you to get out your orange sheet. All right, one we're going to use all the time. We will use it in many, many formulas this semester. It's on your formula sheet. It's very close to the top. It may be the top formula. I can't remember. K stands for what? Kelvin. C stands for Celsius, and 273 is a constant. If you take a college class, it'll probably use the constant with a decimal, which is 273.15. But we round off in high school chemistry. Now, I want you to add this formula to your sheet. It's one of the few times you get to write on your sheet. It is not going to be on the exam, but again, this is one of the extras that y'all have to do in honors. You have to be able to change Celsius to Fahrenheit. So Celsius equals 5/9 F minus 32. Okay? So either at the top or the bottom. All right? Write formula. On the formula page, page 3. All right, find your formula page, page 3, and write the formula. If you don't write the formula and you need it on a quiz or a test and it's not on your formula page, don't come to me and say, Ms. Wall, what's that formula? Because I'm going to tell you, I don't remember.
Yes, I will.
Yes, you will do, because I'm going to tell you I don't remember. It'll come back to me, though. It's just not in my brain right now. I have a senior moment for about 20 minutes to an hour and a half, depending on whether it's a quiz or a test. All right, does everybody have the formulas? Yes, no? Okay, so if you have an easy problem, such as I give you 175 K, and I want you to find degrees Celsius, can I assume that everybody would know which formula to use and how to solve? I can't assume that.
Yes.
Okay, what formula would I pick, Caesar? The which one? No, because this does not have an F in it. I would not want this one. I would want to pick which one? I would want to pick the top one because this one has a K. That has a K in it. I want C, and that has a C. This formula has a C and an F, and I wasn't given C and F here. Does that make sense?
Yes.
All right, so the 175 is going to get plugged in for the K. So if I just write the formula so we can model it, 175 goes where K is. I want C and plus 273. So if I'm looking for the C in math class, what would I need to do? Subtract what? Subtract 273. So C is going to equal, I think I did this earlier, I think it's negative 98. Okay? Now, when I write my answer, I can't just write C equals negative 98 because C is the variable. It's not the unit. So when I want to write my answer, I have to put degrees C on my answer because that's the unit. C is just the variable we're solving for. Are we good with that formula? If we were solving for K, we'd just be adding. Everybody good? Okay. Can I turn the page? Need me to wait, Victor? I don't mind waiting. Okay. So let's say we went overseas. And we saw it was going to be 28 degrees. All right? Maybe some of you were born in another country or you've traveled widely and you know what 28 degrees Celsius means. All right? This wall is not very well traveled. I would look at 28 degrees Celsius and be like, dang, do I need to wear shorts today or jeans and a coat? All right? I wouldn't know. I'd need to convert that because I would not know how to dress. All right? So, what would we do? What formula would we need? A Celsius one. So C equals 5/9, F minus 32. So, when I use this formula, this time my Celsius is 28 equals 5/9, F minus 32. Now, just like with every formula that I will use this semester, again, what do I do to solve? I get rid of the fraction. Okay? I told y'all, I was terrible at fractions in school. Not too good with them now. So I get rid of the fraction. To get rid of the fraction, all I do is cross multiply 28 times 9. 28 times 9 is 252. And then I have 5 times F minus 32. And now my fraction is gone. Now, you can choose at this point how you want to solve. There are multiple options. You choose. Do you want to distribute? Do you want to divide by the 5? Y'all choose. You're in math class. Choose which one you liked better when you were in math class. It doesn't matter to me. I'm pretty flexible. Which one do you like? What'd you say back there, Octavia? None of them. Okay, well, we got to pick one. I know y'all hate math. All right, but we got to pick one. Distribute. Okay, I'll do that. So 252 equals 5F minus 160. All right, so what would we have to do from there? Add 160 to both sides. So we get 412 equals 5F divided by 5. So we get 82.4. All right. Now, rounding for significant digits, I gave you how many?
2.
So I need to round it to 82. So, if I saw 82 degrees Fahrenheit, I would know I was wearing shorts. Okay, some of y'all would be fine in jeans. Some of y'all have on coats, but, you know, I'm dying in here. I could not manage in jeans and a coat. Questions? Y'all would be appalled to know what my room temperature is at night. Everybody good with the formula? All right. All right. Mine's on about 64.
1.
All right. So what is heat? All right, so what is heat? All right, we have to change a couple words. Heat is a measure of the sum total of all the kinetic energy of the particles in a sample of matter. It's a measure of the sum total of all the kinetic energy of the particles in a sample of matter. Okay? So, tell me what the difference is between temperature and heat. Yes. Okay? That's exactly it. All right, so temperature is an average. Heat is a sum. Now, aside from those two definition words, how does that really impact how temperature and heat are different. Okay? So let's say we have a teacup here. In it we have some coffee. It's the only thing I can draw. Don't get excited. Okay? Because this next one's going to be a butchering. Tub, shower, whatever you want to call it. All right. I told y'all I can't draw. Now, which one has the greatest temperature? Yes. Okay? For those of you who've ever made tea and boiled water or made coffee, it's usually going to be either boiling or very close to boiling. Okay? So this one will have the highest temperature. Okay? It's usually going to be pretty close to boiling. Now, I'm just going to take a shot in the dark here and guess that we've all had a bath. All right? I'm going to hope yes. After spending all day in here, I'm going to need one by 4 o'clock. So, if we get in the bathtub, pretty certain that none of us take a boiling hot bath. All right? We would scald and burn off our skin. So I'm pretty certain that the bathtub is not going to have the same temperature that the coffee or the tea is going to have. All right? Now, which of the two will have the highest heat?
Bathtub.
Why?
Because it's got more liquid in it, so there's greater sun.
That is correct. Okay? All right. The tub has more heat for the exact reason that Charlie said. There are more particles. Okay? Heat is about mass or size. Okay? So the greater the particles, the greater the heat. So currently in this room, I am putting off the largest amount of heat. I have the greatest size, so I am putting off the greatest heat. I don't say that to be rude. It's just the truth in terms of science. Okay? I may not have the greatest temperature, I might at the moment because I'm moving the most. All right? But I do have the greatest heat because I have the greatest mass or size. I have more particles. If we talked about a frozen lake or a swimming pool right now in August when the temperature is 90 degrees, okay? I enjoy lunch to be outside the courtyard at 90 degrees. All right? Which one would have greater heat? A frozen lake or a swimming pool in August? Frozen lake. Why would the frozen lake have more heat? It's massive when you consider a swimming pool. Okay? So even though the particles are frozen, they're still moving, so they have some motion, and there's more of them by a huge amount, so it has more heat. Okay? So when you add all of that motion together, it's still going to be more than the particles that are moving faster in the swimming pool. Okay? So the frozen lake will have more. Okay? Are you with me on size? It gives you more heat. Yes? Okay. Now, how do the units and the formulas and how we measure it compare? All right, so the units for heat are joules, not spelled the way the other is, and it's the SI unit. Of course, now thanks to, I don't know if I should refer to it as tobacco, because it's not technically tobacco, but now that those have become popular, it's easy to tell you how to pronounce it. Once upon a time, we had to compare it to jewelry, because those fancy little smoking devices didn't exist, but now everybody knows how to pronounce joules. Calories are the English unit that you're more familiar with, and later in the semester, I do have some word problems that will use the English units. I think I have one or two on some practice work, but early in the semester, we will stick solely to joules. All right, the equipment that we use to measure heat is not a thermometer. We use what's called a calorimeter. Now, all of the calorimeters that we had when I started working here were largely broken or missing pieces. They're fairly expensive to replace. And so, being a poor school, I can fix this pretty easily, and I can afford them. So I got a food line, and I buy y'all some seriously high-tech equipment. I get y'all styrofoam cut, and it works beautifully. Oh, there's air blowing out of that. I think I'm kidding. There's sweat running down my back. I may have to borrow Miss Bowers' deodorant for today's out. Or stand up wind from people. Zoom.
Bag if you need it. Let me know. I got some in my bag if you need it.
Thanks, Charlie. I think I wore enough, but I wasn't planning to come to work with no air conditioning
I
today.
got that Old Spice for you.
Okay, I wanted to smell like a man before I left. All right, so the formula we're going to use is on your reference table. It's about midway down. And it is Q equals. And we will do a lab of this, I hope, at some point during the semester. I typically do it towards the end when we do heat diffusion and heat vaporization to differentiate how those formulas are different from this formula. Q equals M. It's a Q. It's a lowercase q because the one on the reference table is lowercase. Once upon a time, it used to be a capital Q. They changed it to a lowercase a few years ago. And CP, and then a triangle T. Why they changed it to a lowercase instead of a capital, I have no idea.
Is it weird to you?
Yes, it takes me years to get used to the change. I had to look first period to see which one it was again, because I can't remember. And sometimes it's a lowercase on y'all's and a capital on physical sciences. No, it doesn't.
What's the word?
I have no idea. It's the same formula. All right.
That is spelled black.
All right, so what do these things stand for? Q stands for heat lost or gained. All right, Q stands for heat lost or gained. M stands for what? It's pretty universal in all formulas. That's mass. CP stands for specific heat, and this is on your reference table. So if you don't have it given in the word problem and you need it, you can find it on the reference table. Delta T stands for change in. Anytime you see a triangle, and you might remember from seeing that in math, the triangle means delta. It's a Greek letter, delta, and it means change in, and whatever's behind it is what it's changing. And since T stands for temperature, it means change in temperature. Okay? We have a lot of deltas in physical science, so change in time, change in distance, change in velocity. In our case, this is change in time. Now, what math operation are we going to use when we say change in? What do you think change in means? Did you say, Mo? How much the temperature went down or how much the temperature went up? So what are we going to do to calculate that? Okay, one or the other, either add or subtract. Subtract. Okay, every time it says change in a math formula, we are subtracting. Now, because we're calculating Q, This will always be the positive difference. We will do some math at the end of the semester that has a positive and a negative. However, this formula is always going to be a positive difference, so we're not going to have negative numbers. Okay? It doesn't matter which way you subtract. If you get a negative, take it off and make it positive. All right, we got it? With what? The plus difference means positive difference. So if you get a negative, put in absolute values if you want to think about it that way for math class. It's just an absolute value. It's a positive difference. All right, we there?
Yes.
Because I'm going to make this go away. Going once, going twice. Gone. All right, so if we look at this question, write it down. So you've got one as a sample. Hopefully we'll have a chance to do two. We might only have a chance to do one. Because, Sunday night when you decide, oh crap, I might need to do my homework in case of small checks, you're not going to remember how to do this if you don't have a sample. Mosquito. No, missed it. I didn't get it.
Yeah, it's been over here.
Yeah, I know. Yesterday I managed to get two, but missed that one. I know. They told us they could fumigate, but in order to fumigate, they have to turn all the air off in the whole building. And it had to be off for several days. So they told us that we could just adjust and kill the bugs. They would go away with the air. Slowly but surely they would go away. Okay? Sweet. Now as long as the next week and a half, and they're still here. They're going away though. All right. So if we look at the question, okay, we know that these are our variables. When you read the question, Q was heat lost or gained, CP is specific heat. Unless the question says, what is the specific heat, you are not looking for CP. Okay? Did everybody hear me say that? Unless it says, what is the specific heat, you're not looking for CP. You kill it over there if you get it. So, when it says how much heat is gained, you're looking for what letter? You're looking for Q. So the other three have to be in the question. So, what is 15.0 grams? That is a mass. Grams is always a mass. So you know that has to go here. All right? What is a C? What unit is a C? That's a Celsius, so it has to be a what? I heard it back there. It has to be a temperature. Okay? A Celsius has to be a temperature. That's why we learn these units early on, so it would help you know where to plug it in a word problem. All right, so what are we going to do when we have two temperatures? That's what this difference is, change in temperature. So you're going to take 67.5 and subtract 45.1 and get a difference, okay? With those two numbers, subtract them. Now, you might have a word problem that just says the temperature increased by, and it might increase by, what's the first period? 2. Thank you. All right, what'd y'all get? 22.4? All right, it's 22.4 degrees Celsius. All right, so we don't have any other numbers. CP stands for specific heat. So what are we going to do to get specific heat? Did you get it? Very good. Yes. So find your orange sheets. All right. I gave you iron. So now, look up iron. Find the column that says specific heat on the front.
0.449.
Yep. 0.449. Now, the unit at the very top says joules over grams degrees Celsius. Okay?
Pull the bucket out right here.
Uh-huh.
Don't empty it.
Okay.
That means it's just full.
Okay. All right. So, once you have those three things, you're ready to solve. So, the formula is Q equals M CP delta T. We need Q. M is 15 times 0.449 and times 22.4. Now, if you look at your units, I have grams and grams, so grams are going to cancel. I have Celsius and Celsius, so they're going to cancel. So I'm going to be left with what? Joules. Okay? So let's calculate and see what we get. 15 times 0.449 times 22.4. All right. So I have my answer. And now I need to round for significant digits. So what am I going to do? How many do I have here? How many do I have here? And here. So I need 3 in my answer. So I can round it to 151, or if y'all are the dropping off variety, 150 with a decimal. And joules. Doesn't matter to me which way you do it, as long as it has 3 significant digits. Questions? Feel okay about that? All right, let's try one more, and then I'll give you homework and we'll be done. All right, this one says, what is the specific heat? Yeah, what's up? Dropbox. Yep. All right, we have it. So what are we solving for this time? CP. All right, so this time, since we have less time, I'm not going to write down quite as much. So we have Q equals M CP delta T. All right, we're looking for specific heat, so which of those letters is specific heat? So we're looking for CP. That means we got to have everything else. What's the easiest one to always find? So what's my mass? 525.2. Okay. What do I do with the temperatures? Okay. So 112.1 subtract 63.6, and I get 48.5. All right, so what's my heat? Yeah, that's Q right there. So 565.4 goes there. Now, you're sitting in math class. What do you do to solve? You need to do what with those two things? Multiply them. It's called combining like terms. 525.2 times 48.5. And you don't have to write this down on your paper like I'm doing. I'm just illustrating for the purposes of teaching class. Okay? And then do what? Divide. I got 0.022. All right. I need how many significant digits? 4, 4, 4, 3. So I need one more. Now, I can't remember this unit. I got all these weird units running all across the board, right? And I need a unit. Where can I find my specific heat unit? Orange chart. Look at the column that says specific heat. See the column that says specific heat? Right up there at the top? There's your unit. Joules over grams degree Celsius. And you got it. Okay? Now, there's 2 samples. Your homework tonight or this weekend is a half a page. There's 6 questions. It's all heat and temperature. Our quiz on significant digits is Monday after we go to homework. There's no partial credit on quiz Monday. So make sure you know your significant digit rules. You either calculated it right or you didn't. Huh? And then we're going to move on to physical and chemical properties. Significant digits. This one we're supposed to have today with calculated. Then we'll move on to physical and chemical properties. And change. We might get to the lab on Monday. If we don't, it'll be Tuesday. And the test, I'm pretty sure we're going to make the test on Wednesday. Did everybody get a half sheet? And I will try to have your lab papers